thank you everybody for attending. My name is Nick Tam. I'm the architectural representative for WR Meadows here in the South. And as we get started, I want to give just a quick background on WR Meadows if you're unfamiliar. We are a manufacturer of Division 3 and 7 products. That's been the case really since our inception in 1926, along with the fact that we are private and family owned. As of January of 26, we are officially at 100 years old. Some exciting times for us as we move forward as well. And that includes our continued growth throughout all of North America. With that, you're going to see a lot of regional offices that are both for operation and as well as stocking for our materials. This includes us manufacturing over 350 different product offerings, and that will probably continue to grow. And just to give you an idea of where we are located, you'll see that we have a lot of manufacturing facilities kind of spread out with a few stocking warehouses. Stocking warehouses highlighted by the gray dots, with manufacturing and operations highlighted by yellow. Here for my particular location, we operate out of Fort Worth, Texas, and supply that territory given. And if you are curious about what branches serve particular territories, you can contact us and we'll get you in contact with the appropriate branch. So since we are on the set of waterproofing, we are manufacturers of pretty much everything below grade and under slab, and we are going to be manufacturers of one particular waterproofing for vegetated green roofs and pedestal paver roofs with hot apply. And as we move forward, this is going to be AIA accredited, so this will be non-proprietary. And thank you all again for attending, and let's get started. So what are we really going to be going over? Well, obviously we want to understand waterproofing in general, but we want to understand why we select certain materials over another. This includes discussing some durability factors when we select these materials, not only for specification, but even just for the sake of applications. We'll talk about critical performance standards that we typically will see in specifications, but also some that are just true definitive standards for waterproofing membranes, whether that be industry standard or code compliant. We'll also talk about some key checklist items that we do need to cover in pre-construction meetings. Believe it or not, a lot of the problems that I have seen on job sites could have been mitigated just from having a thorough pre-construction meeting with effective communication. And we're also going to showcase some common issues, some that could actually be very detrimental to not only the project schedule, but overall the quality of output from our installation team. So when you think about product durability, what are the factors that we truly consider? Obviously, we want to make sure we have products that are going to meet code, are going to be industry compliant, but we have to think about their application type as well, among other factors. So what materials can be installed vertically and what materials can be installed horizontally? Truth be told, there are many materials that may be able to be installed for both applications, but it's always going to be manufacturer dependent. We do see some materials that could be only installed horizontally, but a competitor may actually have material that can be installed in the same manner, but also vertically. Where does that become an issue? Ultimately, it can become an issue and confusion of which products we should be using in certain areas. What about the UV resistance timeframe? If you have something fairly large scale, obviously we may need to opt for something that could have a little bit more UV stability, but it may not even be a matter of how long it can be exposed. It may actually be a matter of how long can we wait until it's covered up? And covered up means how long can we wait before it's protected? What about compatibility? What are the adjacent materials that we have to consider for compatibility? When it comes to time of installation, which product could be faster? Which products can be ultimately better for the quality of output? And also, which products do we need to install faster for the sake of the project schedule? We see a lot of fast track projects where it may not be as useful for us to use hot applied materials, which we will explain later in the presentation. So when I'm speaking on accessibility to transitions, one thing that I do think is very important is how do materials transition, and do we have standard CADs available that really reflect it? Believe it or not, though, a lot of standard CADs we see don't actually reflect what we see in the field. And because of that, sometimes it's hard to actually implement products into design that ultimately are going to be beneficial for our contractor to put shop drawings together, because obviously they're going to follow manufacturer's minimum installation guidelines, or so we hope. Also, what about compatibility between differing products? This is also very true when you think about attaching new to existing. And we see this quite a bit actually when it comes to deck waterproofing, or if you have a structure being installed next to an existing structure. So if we need to, we may have to incorporate test application areas. And ultimately, we may even need to speak with manufacturers in terms of their chemistry makeup and if they have any concerns. What about the accessories that we utilize? A lot of the accessories for one manufacturer may be different than accessories from another. Accessories that are not from one manufacturer but come into contact with one based off of the applications can ultimately be a challenge because it's not just about chemical attack. What about adhesion? Long-term bond is very important for making sure that building moves, that the materials can stay bonded if they happen to expand and contract. So, what are some of the critical standards? Now, this is just going to be a little quick excerpt, but typically for a lot of true waterproofing materials, these are going to be some of the examples of standards that we often see specified as reference standards. When it comes to below grade vertical wall specifically, ASTM 5385 is going to be your true common standard for hydrostatic head resistance. If you're curious about what that standard is, it's going to be a pass-fail rate of 230 feet of hydrostatic head pressure resistance. So in other words, if you have a wall below grade that happens to be 230 feet deep, then that's potential for hydrostatic head resistance or hydrostatic head of 230 feet. Now, truthfully, we don't see too many walls that are near that depth, but ultimately you want to make sure your waterproof membranes can accommodate such a standard for the sake of its long-term durability. ASTM 96, most waterproofing materials should be water vapor impermeable. And so for ASTM 96, this is a common standard we do need to see referenced. And truthfully, they're going to be usually around 0.01 perms or less. I would say more commonly, materials that are waterproofing are going to be less than that. So they will differ than your plastic vapor retarders that we see that are usually class 1, 0.1 perms or less. And so make sure we verify that in product data. Now, ASTM D412 or D5329, depending on which testing a manufacturer decides to use, elongation is very important. And same thing with ASTM D412 for tensile strength. So the way to really explain these is that tensile strength represents how much can a material flex until it ultimately tears. As we all know, structural concrete is usually what we're waterproofing. And so as it expands, it contracts, any other type of seismic movement that can cause some challenges, you want to make sure these materials can stretch. So how long can it stretch before it ultimately tears? Elongation, almost the same. However, what this is really going to represent is how much can this material stretch, but also recover. So in other words, how much can it stretch before it ultimately doesn't have the ability to recover and just renders useless at that point. And so these materials that we see need to be able to expand and contract along with the concrete. When it comes to pre-construction meetings, I have a little bit of a checklist. Who needs to be involved in these pre-construction meetings? We understand that sometimes it may not always be like this just due to schedule, communication, and just the fact that every project delivery style can be a little bit different. But for sure, I want to see obviously the waterproofing installer. Along with the waterproofing installer, who are they going to come into contact with? Obviously, concrete. So it may benefit to have our concrete ready-mix companies involved as well. If we have shotcrete involved, whether it's going to be an initial application for blindside waterproofing, or if it's going to actually be shot against blindside waterproofing, it might benefit to have the shotcrete installers as well. Who's constructing the backfill? Backfill is very important in terms of, are they going to understand how it could be installed to make sure it doesn't rip waterproofing off the wall? And in relation to concrete rebar, believe it or not, and this is especially true for blindside waterproofing, we will see rebar put up before all the detailing is complete. If rebar's up and detailing isn't complete, it's going to become a major challenge for installers to actually install the detailing needed. And then plumbing, particularly if you have penetrations coming through your wall through the membrane. It's okay if it's coming through the membrane, you're going to seal it, right? What about if it's a cluster of penetrations? If these penetrations don't have, I would say, probably a hand's width in between each one, sealing that penetration is going to be almost impossible. And this is ultimately where we may have to get creative on how we waterproof these areas. But if possible, we really want to see the manufacturer's rep in attendance. Who's the one writing the warranty? Your manufacturers. Who's the one providing a job site observation for their particular material? It's the manufacturers. Who should know more about their products than anybody in participation? It should be your manufacturers. And so a manufacturer's rep can only add more benefit and make sure that we take care of any potential issues that happen way before we actually start the project. So what are some of the discussions? Well, what do we expect from manufacturer's rep participation? Obviously, as a manufacturer rep, we want to make sure that we get products correctly specified and ultimately correctly submitted, and shop drawings are pretty clear and concise. However, how many times do we expect them to be on the job site? Sometimes we may get asked, we want you on the job site every week. Well, do you want the same field report 5 weeks in a row? Because believe it or not, that may be all that's accommodated. Do we really feel that 5 weeks of the same report are going to be beneficial? And is that really efficient for a manufacturer rep's time? One way that I like to look at it is, what's the scope truly look like? If it's a large scale application, maybe we can offer 2 to 3 or 4 reports of that particular wall before we move forward. I think it creates a little bit more efficiency. If it's just a single elevator pit, you could probably get by with maybe 1 or 2 reports before it's completely done. What about the scheduling? If we're going to backfill, what do they need to know before they backfill? Well, they need to know that this waterproofing needs to be protected before they do it. They need to know that it needs to be sealed and protected before they do it, and that an effective transition is carried out before they'd even backfill at the bottom of the foundation. What about the communication between trade? So a lot of the communication challenges we may see is just that we get ahead of ourselves, because it's no surprise here. We try to keep the project on schedule. Before we get ahead of ourselves, this is where that scheduling actually really plays into part. And so we can talk about some of the precautions, and we can talk about what needs to be accounted for before we move forward. And one thing I also want to make note of this, when third-party building envelope consultants are part of the project, which it's a great benefit if they are, that communication really needs to be between our consultants and your manufacturer reps, along with our building envelope installers. And so typically manufacturer reps are going to be working with installers, but they should also be able to provide information to consultants when it's appropriate. What do I like to see? Well, I like to see a plan review to start before we even really get into understanding what products we need. Reason being is because if I see a plan view, then I can maybe understand what type of waterproofing materials are appropriate. Now, it may seem simple. Okay, if we have a below grade wall, we need below grade waterproofing. It could be sheet, maybe fluid. But from this plan view, this is a building that's actually connecting to an existing structure. So if you have the building highlighted in red here connecting to this building that's over here in the gray, well, if it's below grade, what is existing on this structure on the right? That's actually very important to know, because if it's an existing dam proofing, or if it's somebody else's waterproofing, or if we can't tell what it is, that might actually create challenges in terms of what we can select. And so what I usually recommend is a test application in some of these areas, but these by themselves may call for a meeting to discuss before we start just moving forward. From construction documents, one thing I will say is that I like to ensure that compatibility is actually accommodated, even from a construction document standpoint. So to highlight this one here, what we have specified is a single component polyurethane waterproofing. And considering ASTM C836 is the listed reference standard, usually this is going to be a deck waterproofing application. So that is completely fine. Very common product that we will utilize in the industry. One thing to note here is that we do have an accessory that is listed as a protection course. However, what is listed here is a semi-rigid sheet that is also going to be an asphaltic material. If you didn't know, asphalt is actually not compatible with polyurethane. And so usually for an application like this, especially if it's for protection, and depending on thickness considerations, usually a protective drainage board may be utilized, or we may have to utilize something like a plastic sheeting to be installed underneath this protection course, or just use a plastic sheeting for protection in general, depending on the manufacturer. So what is not compatible? What? Amongst most manufacturers, rubberized asphalt is a common material that we will see, or composition. So whenever it comes to, say, detailing, make sure that any termination masticks are not of polyurethane or silicone. If they do come into contact with rubberized asphalt, they will either chemically attack, or they just will simply not bond. And then if for some reason we actually are in consideration for connecting rubberized asphalt materials to maybe TPO roofing, that should be a major challenge, just because we do see sometimes rubberized asphalt flashings come into contact with the TPO roofing, and that can actually be a big issue. And so if you want to know what I typically recommend is, if the flashing is going to have a polyethylene facer, just make sure the TPO transitions on top. If we are connecting a section of amenity deck that is hot applied to an exposed TPO area, we may want to bridge with some type of hybrid transition membrane, or maybe have a metal flashing that can be the bridge in between so they're both not coming into contact. But this will all depend on design, exposure, as well as compatibility of manufacturers. So one of the reasons why I put this is to say that concrete contractors can be good waterproofers. It's just a matter of if they go through the training and that they get enough experience. However, we do see in some situations where concrete contractors may take on the waterproofing for an elevator pit. The challenge we may see with that is ultimately there's going to be some misunderstandings that oftentimes do happen in terms of what needs to be taken into consideration before you install. These are real applications from real projects. And if you're curious of what this is, at the bottom of the wall here or at the foundation, you actually have a blindside membrane that was used under slab and it was going to turn up and have the self-adhered sheet membrane shingle on top. Well, as you can see here, aside from that fact that the concrete profile is just not very smooth or consistent, you actually didn't get any transition. You actually don't even see a protection board there, which is a problem because you need protection for all waterproofing. And then what you also see is that, look at the middle photo here. You have a corner here that basically we just rolled a membrane clear across from the walls to the corner. Typically on corners, we do recommend having separate detailing strips. And the reason being is because a lot of movement happens at corners. And if you get enough tug and pull at these corners, especially if it's extended beyond the wall, it may actually potentially pull it up. And so we want to see coves or cant beads underneath those corners. And we also want to make sure a separate transition strip is accommodated. What happens when multiple trades are responsible for the building envelope? Now, this is important because, again, for a lot of slab-on-grade applications or below-grade applications where the concrete contractor takes on maybe the plastic vapor barrier, that's perfectly fine if that is the case. Do note, though, that if we are having to make a transition to the waterproofing, we oftentimes will still see a dedicated waterproofing installer be responsible to make that transition. So what do we actually need to consider for when it comes to the communication? Well, how much of that vapor barrier needs to be extended out beyond the face of the foundation and turned up so that the waterproofer can actually make the transition? Do they need to anchor the vapor barrier, or do they need to adhere it in some manner? What does that adhesion look like? And ultimately, do they use a tape, or does the manufacturer make a statement saying we need to have a termination bar to anchor it? If we're going to shingle the waterproofing to a vapor barrier in this situation, well, what does that look like with a fluid applied? Is the fluid applied even going to be able to accommodate? And so this is where we may have to offer something a little bit different, such as this self-adhered sheet transition membrane. A fluid applied can accommodate, but it's going to be a bit challenging. And so definitely have that communication with your manufacturers if you can. And for some of our larger scale projects, what we may see is that you'll get multiple waterproofing installers handling different scopes of work. For example, we may actually have a waterproofer doing the below grade. Think of a blindside application below grade. But then we have an air barrier manufacturer working for the above grade applications. That's going to be separate at the waterproofer. So if that is the case, especially in situations where we're actually going to make the transition between air barrier to the waterproofing, because we will see that in some, then what needs to be accounted for from the waterproofer to ensure the air barrier installer can make that transition? I think a good example of this is that we will see blindside applications where they actually need to extend a tail of waterproofing above so that we can make a transition for the air barrier installer. And usually this will be accommodated with either a self-adhered sheet membrane, but if they don't extend the blindside up at least a couple feet, I would say that transition is not going to be accommodated and it becomes an issue. Surface prep. Who is responsible, the concrete contractor or the waterproofing contractor? Well, in a way, both. I like to look at both sides of the scale if possible. Our concrete contractors, when they pour their concrete, they're ready to get off the job and we completely understand that's their scope of work. However, what happens if concrete is not consolidated well, or if we just happen to have profiles that are not very smooth, either exposed aggregate, a lot of honeycombing? The challenge we may see is that our waterproofing installers can't install their materials to rough concrete. A lot of times it may not be factored into their scope to repair the concrete either. So Who's pointing the finger at who and who needs to fix it? Really, I would say that this is going to be dependent on really our project delivery. But I would say this, if we have a concrete profile that's not very smooth, I would like to see concrete contractors be able to repair it with just a simple repair mortar. If our waterproofing installers are going to be asked with repairing it, then it needs to be understood that that's not initially factored into their scope of work. What does the surface prep look like for a wall, though, to receive waterproofing? Well, no surprise here, I mentioned earlier, we want it to be smooth. But that also includes the fact that let's remove any loose mortar droppings that we may see onto the surface. If that is loose, that means your waterproofing isn't bonded completely to the wall. And then also, if you have any bug holes that are maybe more than 1/4 of an inch, that may be required to fill it. If it's just 1 or 2, you can likely just fill it with the appropriate mastic and then put your waterproofing on top. But if it's a lot of bug holes, it may benefit to just simply repair it with a smooth grade repair mortar. Also, make sure the surface is clean. Dirt is a bond breaker. There's a lot of situations where if you were to look at plastic vapor barriers, we'll see it's not here simply because the vapor barrier has dirt sitting on it. Why is there dirt on it? Well, people are walking on it. When it comes to a below grade wall, well, there's dirt all around from excavation space. So just make sure it's a clean, smooth surface, voids are filled, and ultimately you'll have a good bonded and prime surface for your waterproofing. In some unique situations, it may be necessary to repair the entire wall. This was a very unique condition. I'm not allowed to disclose the project location, but this is a situation where you had originally an ICF foam wall. And with that, we had a waterproofing membrane installed that was not compatible with the foam. So because of that, it failed and the wine room basement of this building was flooded. So when we uncovered it, we actually had to remove all the existing insulation onto it, and it got a the concrete infill profile. The problem is that the profile is not smooth. It's going to be a ruffled, rigid application area. So we may just have to repair the entire wall with the appropriate repair mortar. And if you do that, then we now have a more thorough and clean application surface for waterproofing, whether it be sheet or fluid. So if you are using fluid, as you can see here, much cleaner application. On the right, you'll see that they did protect it with the appropriate drainage board and they did their gravel fill against it. I've had people ask me this question when I presented this. At the bottom of the wall, since we couldn't tie into any underslab treatment, we actually tied in a vapor barrier to extend from the bottom of the wall out a few feet away and put a trench pipe on top. This was an engineering decision and ultimately helped carry water away from the building. And for the most part, I believe this was a successful outcome. So some of the simple details. Terminations. What do terminations look like? Well, anytime you have, in this photo example here, a self-adhere sheet membrane, if you overlap, those end laps need to be sealed. Terminations at the top of the wall means sealing the top edge of that waterproofing with your appropriate sealant or mastic. You also want to anchor it as well. And usually a termination bar is going to be used, and it doesn't matter what type of termination bar you use, whether it's a plastic, a wood, or a metal, just make sure that it is anchored appropriately and that it has long-term durability. Usually when it comes to protection, though, we will use a drainage board. There are other methods of protection as well. We have seen rigid insulation used. We will see oftentimes maybe a 4x8 rigid sheet. The challenge with that on vertical walls, though, is that it creates a lot of joints and a lot of extra anchoring. And typically for most installers, they will prefer a drainage board in that application area. Some of the discussion points. Well, make sure the membrane is not exposed past its UV limitations. A lot of waterproofing membranes may only have 30 days of UV exposure. So if it only has 30 days of UV exposure, well, we need to get it filled. We need to get it protected. Now, that being said, it doesn't mean that getting it protected means you have to backfill against it. It just means put your protection course in front of it. And so protection is to make sure that the UV doesn't cause this membrane to break down. If it's a sheet membrane, if it breaks down, usually what you'll see is a little bit of separation of the plastic from the rubberized asphalt. And you want to make sure you also have a slow backfill. I'll show a photo example of that here in a little bit. If you're curious what UV exposure limits look like, well, if it's a fluid applied membrane, you may see a phenomenon called alligator cracking. If you see alligator cracking like this on top left, it can be repaired. Usually it may require just a simple kiss coat of the same membrane. If you see a lot of true separation, though, where basically the actual substrate's exposed, it may be a little bit more critical and you have to do more full coat applications. And so verify that with manufacturers as well. Shrinkage and separation, I think I pretty much covered that a second ago. And I just noticed that separation is, but you may see the poly be completely removed as well from it. You notice that the membrane, which is rubberized asphalt, is not actually black anymore, starting to turn brown. That's a true indicator that it has been exposed way beyond its limits. So I mentioned a slow backfill earlier. Why do we want to slow backfill? Well, believe it or not, especially if it's a fairly deep wall, we've seen situations where the backfill that they use is actually turning into mud just due to a rain. And if that backfill gets carried out too quickly, it may actually rip the drainage board away from the wall, and that could become a challenge. On something like this, you may experience leaks on the other side of that wall, which in this case, it was actually a football complex where a 30-foot wall on the other side was actually leaking. And so because of that, that becomes a challenge, and likely most owners don't want to re-excavate this entire wall. And so the backfill should be slow, it should be carried out efficiently, and ultimately this should be anchored properly as well. When I mention terminations though, an anchor is not the same as a termination. And so what you'll see in this photo example here is that the waterproofing is behind the drainage board and it is properly protected. It's actually a pretty clean application. However, you'll notice that it was not sealed at the top of the membrane. So just because we smack a termination bar against a drainage board does not mean that you properly sealed it. And so if you have an application that looks like this, they are going to need to go back and make sure they seal that top edge of the waterproofing. But it may also be beneficial to tear off some existing fabric and actually extend it on top of those dimples of the drainage board, just to ensure that they don't get filled from any backfill that gets poured against it. When it comes to complex transitions, I don't think it's any surprise here that a lot of standard CADs may not represent what your fill conditions really call for. CAD details are going to typically be very vague. And so communication and pre-construction meetings for installation, what does that look like for certain applications like this? Maybe this is an elevator pit or just simply a foundation wall. Well, if we are using maybe a blindside sheet waterproofing under slab as opposed to a plastic, blindside membranes are going to bond to the concrete. Well, do we want this tail that we see turning from under slab up, do we want this installed formwork, or do we want to extend a tail out here and then allow this concrete to be formed and poured, and then eventually when we remove the forms, repair the surface if needed? The reason I bring that into play is because we can install these blindside membranes into the formwork, but if you want a little extra QA, it may benefit to actually extend a tail beyond the formwork so that this doesn't have the potential to rip down, because the minute that it rips in the middle of a concrete pour, then that becomes a challenge. If you extend a tail out, we still want it to bond to the concrete, so we may have to have a discussion, how do we bond it? Do we use a mastic? Do we just terminate it with a termination bar? Verify that with your manufacturers. Also, what does it look like when you want to transition your self-adhere sheet to the waterproofing that comes up from under slab? In some cases, we may see it where it actually just comes down and extends down and over. If you want a personal opinion though, it is going to be very much beneficial to actually have a separate transition strip. And this can either be a separate strip that's different composition, or it could actually be the same membrane here cut into a separate sheet. And the reason why we do this is because corners are where you experience a lot of movement. I mentioned that earlier, that you want to make sure that self-adhere strips can actually accommodate that movement much better without the membrane pulling up at a corner. Here's an example of that cove that I mentioned earlier. And I know this photo here shows the insulation board going directly against the waterproofing. That's only if it's required. We do see that application come from time to time, but most applications that I see will actually have the drainage board installed directly against the waterproofing. Now, the reason I want to show this, so this will be an example of an elevator pit, but at the top of wall cannot always be an under slab sheet waterproofing, much like what was used under slab here. So what that means is this: how do we actually have the top of a wall vapor barrier for the true floor on slab or slab on grade application? What does that transition look like? How is this carried out? So to give perspective, if this was a blindside wall, it actually could be very simple, is that this blindside membrane would be used to encapsulate here and we just extend a tail. But in this example, we have a post-applied self-adhere sheet membrane. So because of that, that means we have excavation space, and we're going to have to tie something in here to make sure that they extend up here and tie into the rest of the underslab material. Well, how does this carry out? Well, typically we may have to use a mastic or a two-component membrane that is going to be a chemical cure to ensure that it bonds and cures quickly. But how do you actually have this tail extended up? You may decide that you want to just extend, I don't know, an extra foot or two, maybe use some blue tape, tie it up here if there's anywhere we can tie it. And then they'll backfill after they put the protection course on. Once they backfill, they can lay the tail down and we could tie in the existing membrane. If it's a plastic membrane, what if it's somebody else's plastic different of the manufacturer of the waterproofing? Who decides what's approved in terms of how we actually bond this tail? Are they going to allow this manufacturer's mastic to bond it to it? And ultimately, who's responsible if there's an issue with this application area? These are a lot of big talking points. If you want to know a true rule of thumb, though, typically whoever goes on top of the other has to write the letter of compatibility or the letter of confirmation. Hot and cold waterproofing. One of the big talking points that we will see is which is preferred, hot applied versus cold applied. Now, truthfully, both are great quality products that we see in the industry. A lot of manufacturers may offer both of them as well. And so if you're curious about hot applied versus cold, one thing I will say is this. Hot applied membranes are always going to be designated for horizontal deck applications, especially with conditioned space underneath. Reason being is because these are high robust materials, most often going to be 250 mils amongst most manufacturers. We'll see them in pedestal paver decks, but we'll also see them in pedestal paver roofs and vegetated green roofs. We do see them in split slab applications, especially when the square footage is of great value. And when I mentioned the large square footage area, it's just the fact that this is a very flowable material and you get a lot of yield from this product, which can actually aid in a really good material cost. And it's also a great vapor retarder on its own too. And if it's installed correctly, plus or minus 215 mils, water sure as heck shouldn't be able to get through it. Now, cold applied, though, can offer great benefits. Now, if it's high build, especially for a true deck application, whether it's split slab or pedestal paver decks, these are going to be 120 mils versus 250 mils. One thing I do want to note, though, that it is great for green concrete. The reason why this is very important to bring into consideration is that hot applied waterproofing cannot be installed in green concrete. So ensure that your concrete is cured for 28 days at least before the hot apply membrane is installed. If we are on a fast track project, or if we have concerns about scheduling, then maybe cold apply membranes would be preferred if it's just a simple amenity deck. Also consider this though, accessibility. If you're using a hot applied waterproofing membrane, these actually require equipment. This means a metal jacketed kettle, and you do need a little bit more labor compared to a cold fluid applied. Well, does the deck where we need to install the waterproofing, does it have accessibility for the kettle? What if this is a project where that kettle is going to have to be elevated to an extremely high level? Does that high level almost render it improper? And so in that case, we may opt for a cold applied membrane that's just simply pushed in these 5-gallon pails and ultimately just poured out of the container and spread with the appropriate squeegee or trowel. You may have noticed from the photos that there was some reinforcing fabric. Now, originally introduced with hot applied membranes, if you're curious about reinforcing fabric, it can aid in the durability and the tensile strength of your waterproofing. You will see it in some cold applies, but you will see it pretty much for all hot applied deck waterproofing. Reason being is because there's a phenomenon that is really hard to see at times that is also hard to prevent if you didn't have it. And that is what we call outgassing. Outgassing is simply going to be vapor drive occurring through your concrete slab that can cause something called pinholing at the very top of your membrane, or if it's enough, it may just be these large bubbles. But if it is pinholing and the membrane is black, that's actually very hard to see from the naked eye. So with that, we use the reinforcing fabric in between two coats to basically catch some of that outgassing so that it doesn't have the potential to reach the top of the membrane. For hot applied, usually it'll be an initial light coat, then embed their fabric, and then they'll do their second coat, which is higher yield. If it's cold applied, and it may vary by manufacturer, some may not require the fabric, then you'll actually embed it in between two evenly displaced coats. But we do need to talk about execution. When it comes to execution, this actually is a very clean application. You can see that they did an initial coat and they saw their fabric, but what you'll notice here as well, they decided to do one coat and then they did their fabric across a lot of square footage there. The reason why that this may not be the best execution matter is the fact that, well, they're going to have to go walk on top of that membrane and on top of that fabric across the way and install their second coat. Well, you'll notice that the gentleman here in the photo is wearing spike shoes. Well, spike shoes will puncture the membrane, especially if they decide to walk on the fabric there, that's going to puncture directly through it. These are moisture cure products typically, especially if it's cold applied. If it's hot applied, that material will actually start to set after about 10 minutes. So if you're curious about some of the more preferred execution methods, we like to see coat, fabric, and then we start moving to the next level. And then if you are going to walk on the membrane, maybe try to not wear the spike shoes if possible. But if you do wear spike shoes, then we need to make sure that area is properly back rolled. Continuity. Now this was unplanned, but if we are putting the fluid applied waterproofing on this structural deck and we have this column here, well, what about getting behind that column where it's against this wall? We actually are going to turn the waterproofing up against the wall and then we'll pour a split slab against it. But the challenge is, how do we get a proper application in such a tight space? Because can it affect the warranty? Maybe, especially if the continuity isn't even be able to be achieved. So there are methods that maybe we can do to repair this. You may want to use a strip of blindside membrane that's compatible that you can cut as a strip, slide it in there like a folded taco, cut the slits, let it ride down, and then install the fluid applied on top of it so it can mechanically lock onto it. There may be some type of leveled fill you can do depending on what type of mastics a manufacturer may recommend. But what does the application look like and can it be carried out cleanly? Testing. Testing is very important. When I think of testing, probably one of my favorites is an ELD test if it is compatible with the waterproofing. Reason being is because not only can it pick up if there's pinholes, it might even pick up if the membrane's not installed thick enough. This is going to be an electronic leak detection test. And you may even see flood testing being done where they just flood the surface with water. That is an option. Not my favorite just because it's a waste of a lot of water and then you have to remove the water after it's all said and done. And so an ELD test can be done from third-party consultants as well as building envelope commissioning agents potentially. And then when it comes to blindside, we won't spend too much time just because I would say precautions are going to vary between manufacturers because there's different types of blindside membranes. You may have a mechanically locked blindside membrane where the concrete forms a mechanical bond to fabric, such as the photo shown here. You may have another good product, that option out there where it's a chemically adhered product to where the wet and heat concrete mix is going to actually cause a chemical reaction and it infuses into the concrete wall. Both are good quality bonds. Just make sure that the prep is done correctly. But some of the observations that we need to consider is the side laps. How do the side laps have to look? Well, if it's a salvage edge, we need to make sure the membrane's lined up appropriately. If it's a reverse lap application, which is going to be the case for the blindside membranes, make sure that they don't do a shingle fashion like they would for a post-applied applications. That is something that is very easy to get confused just because it's creature of habit. You want to shingle membranes. At the top of wall, transition to a post-apply membrane. When you look at this photo example here, you'll see at the top of wall, there will be a portion where a self-adhere sheet membrane will tie into the blind side. So we have a little sloped application there. Make sure that we extend enough membrane so that that transition from post-applied to blind side can be achieved. And then as you can imagine, there's going to be a lot of detailing here. And I'll show a photo on the next slide to kind of tie into that. But we want to make sure that the detailing is completed prior to the rebar being installed. And so that's also going to be a matter of what kind of damages are going to occur. And that could be from rebar, some external factors. Somebody decides to weld nearby. Well, they need to be treated before the rebar is installed. And then there may be some tieback detailing that's needed. Now, there may be some preformed tieback covers that can be utilized, really good materials to use if we want to simplify everything. But if we don't, we may actually treat it with a liquid mastic and then some extra fabric or other coating methods. So when you look at this particular photo, the application being done from the installer here, you'll see a drainage board and then a blindside membrane being installed. They're actually going to be doing the overlap detailing later, but you'll see here, they need to make sure that it is in reversed shingle fashion. And then ultimately, as you can see here, it's a lot of square footage. If you're putting rebar up against that, there's a lot of areas that if they didn't have a chance to detail it, it can pose a challenge for the rest of the building. So when it comes to the self-adhere sheet tying into a blindside membrane, a different example is, what about a pile cap? If you have a pile cap where we actually need to waterproof it, and this was actually dependent upon the manufacturer, or excuse me, an engineering review. Well, in this particular situation, you'll have a pile cap waterproofed on the column down to the top of that cap, but then the actual against it's going to have a blindside underslab waterproofing membrane installed. So what they did is that they actually installed a tail of the blindside membrane here, much like that top of wall condition we showed earlier. If we are going to accommodate that, there are certain things that we want to consider. So what you'll see here is that they used the blue tape to tie a tail of the membrane at the top, and that they anchored with a termination bar on top of the self-adhere sheet. Something that needs to be understood though, and this is something that may be commonly missed, that is very easy to miss and it's understood, but you'll notice that behind this termination bar, there's a liquid mastic behind it. If we don't put that liquid mastic behind it, that means that every screw that's shooting through this membrane is now for water to leak through. If you're curious what happens when this occurs, you may see leaks at the actual joints around the column. So this is something that is very, very critical. And if we don't actually put it behind it, then we may need to coat the termination bar completely, or at least around the top of the screws and around the edges of the bar. Not a preferred method. We much prefer what we call wet setting, which is take your liquid mastic, goop the termination bar, install and screw, and you're in good shape. Once they backfill against that column, then they're going to lay down this blindside membrane and they'll tie it into the rest of the actual slab sheet application. And to give some perspective, that column that you see there, that black mastic that you see, or it's actually going to have some fabric as well, that's actually the tie-in that we talked about, and the tail that was untaped and laid down to tie into the rest of the underslab sheet membrane. If you're curious, that wall that's poured in the very back there, that is going to be the same material that's used for the underslab, but the wall was poured first. And so everything that's here underslab was done after the wall pour. And to finish off, when it comes to cementitious waterproofing, there are a variety of different options that are out there and a variety of different application types. If you're curious about what type of cementitious is common, usually crystalline is one of the more Kleenex opted types that we see. It can be either an integral mix, is a very common application where they will take this mix of concentrated powder and then they'll put it into the actual concrete batch. This can be done at the ready-mix plant or it can be done on site. So what it will do is ultimately when it's poured and concrete is achieving its pure, it's going to plug the pores of the concrete. Basically it crystallizes, creates calcium silicate hydrate, and makes it waterproof, makes it water resistant. Now, there are going to be situations where we may want to opt for a coating as opposed to the admixture, or we may opt for both. It's all going to be dependent on maybe some complexities, or it could be even something where we have a restoration issue. So if you're curious of where I like to see the admixtures, I like seeing it in structural concrete. I like to see it on very large slabs that are going to be poured. And I do like to see coatings a lot of times on anything that's holding in water. So if you have a water tank, maybe we have a water and wastewater tank that we want to make sure it can hold the water in. Crystalline coatings are a great option in that regard. Filtration centers. We see filtration applications all the time where crystalline coatings can be used, because if we have to empty out that tank, which oftentimes they are emptied, they can be exposed. They don't have to worry about UV exposure degrading them. But another good application that may have not been talked about as much, we're starting to see a little bit more now, is if you have an elevator pit, these are great options to coat the inside of those elevator pits. Even if we have a post-applied membrane that's installed on the outside or the exterior side, these are breathable materials, which means that if we install it on the inside, it's a good potential that that concrete can still dry effectively. So during the build-outs of an elevator pit, if water happens to get accumulated within the wall, even after the post-applied membrane has been installed, the crystalline coating can actually make sure that the liquid water can't pass through, but it should still be able to dry inward. Whether this is going to be a preferred application or preferred engineering decision, we will defer to engineers in that regard. If you have a leaking basement, another great option for where these materials are often used. Thing that needs to be discussed though, epoxy coatings are great materials for very durable applications in certain areas, but do not allow it to be used in place of an area where there's already existing waterproofing on the other side. And the reason being is because we will have basically two vapor retarders in that regard. And if there is water that's breached in the concrete, it will have a harder time getting out. And it's basically going to either cause the concrete to blow out, or you may actually see just delamination of the membrane, such as this here. And even if there is, say, a below grade application, but we're trying to put a coating on the inside, we will see situations where an epoxy may actually bubble, and just that's due to excessive vapor drive. Or if there's liquid water permeating through, it can cause it to bubble as well. And depending on how much excess of that water or vapor drive, you may actually see the epoxy peel kind of like a wet band-aid on skin. So, such as it's shown on the right photo. But there are a lot of good epoxy coatings that for certain applications. I highly recommend epoxy coatings, maybe in secondary containment areas that are collecting maybe acidic materials or some other type of contaminants. And when it comes to warranties, well, what do we have to do to achieve the warranty? And that's going to depend on your manufacturers. What I will say is this: I'm not using the term approved applicator, I'm using authorized. Authorized applicators are typically going to be the contractors who have good extensive experience in this area of work. The reason why this is important to consider is the fact that we will see situations, and we have seen it with air barriers. We're seeing painters oftentimes get awarded for air barrier work, but they may not be as well versed in air barrier applications. So you can verify with your manufacturers if they may have some waterproofs they've worked with in the past, or maybe they will approve or authorize somebody to install their materials. Ultimately, though, that will help determine if you're going to get the warranty that you desire. What type of warranty terms do we look for? Well, that depends on what's specified. We will see typically between 1 to 10. I would say that is very common. If it is extended up to 20 years, verify that the manufacturer of the system will provide that, because just because it is specified does not mean the manufacturer will provide it. And what I mean by that is it may be based on volume, it may be based off of their system, and it may be based on the fact that if we're going to install a warranty like this, they may have a fee. So verify that with your manufacturers. But if you want to have a warranty be achieved, you want to authorize applicators. You want to have at least some of observations of the applications if possible. And you want to make sure that the manufacturers can provide based on the warranty term. And then we do highly recommend third-party inspection or commissioning. Waterproofing or building envelope consultants can add a lot of value, and it only is a nominal cost compared to the cost to remediate and deal with litigation down the road. And so one thing we will say is that when commissioners and consultants are involved, their communication with the installers as well as the manufacturers of the waterproofing material can greatly benefit the project as we move forward. Inspection and commissioning from third-party consultants can be of great value to your projects. Thank you, everybody, for attending.